Good morning, good afternoon, hello everyone. Welcome to the UP42 Webinar, Leveraging Geospatial Data for Construction Monitoring. My name is Claudia Bielinska, and I'm pleased to welcome you to today's webinar. Before we start our session, I would like to share with you a couple of technical information. On your right side, you can see the chat. So in case of any question, please type in your question there and we will answer. Of course, at the end of the webinar, we'll also have the Q&A session. So we will try to answer your question during this session. This webinar will be recorded. So a couple of days after the webinar, please expect email from us with the link to the webinar. Today's agenda of the webinar is very interesting, I have to admit. We have three excellent guests from our partner companies, Vexel, Airbus, and our own UP42. So today, the webinar will be divided into three different parts. First part will be dedicated to aerial imagery. The second part will be dedicated to satellite imagery. And the third part will be dedicated to UP42 platform. First part will be led by Andy Millard, customer advocate from Vexel company. Andy will tell us about using aerial imagery for construction project planning. Then second part, led by Oliver Lang, head of SAR monitoring from Airbus, will be about interferometric radiometry, so monitoring surface deformations using InSAR. And then at the end, Alex Bishop will guide us through the UP42 platform and show us how easy it is to access geospatial data through UP42. Before we start the session, I would like to ask you to answer one quick question. What type of remote sensing data do you use? It's good to have the knowledge of our users, of the attendees, what kind of data sets they are using. On your right side, you can see the polls. So please let us know what type of remote sensing data do you use. Great, thank you very much. I see the answers. Okay, I think that I can move on to the first part, which will be a short introduction to UP42 platform. Hopefully, most of you are already familiarized with the UP42 platform. If not, please let me just give you a very brief introduction. So UP42 platform is a cloud-based platform, is one common environment for both data access and data processing. On one hand, it's a marketplace. Thanks to our cooperation with over 77 different partners, data providers, working worldwide, delivering aerial imagery, satellite imagery, different types of elevation models, and other data sets, our portfolio of geospatial data is really full. So in case you conduct different projects using different data sets, this is the place where you can have easy access to different data sets. On the other hand, it's a developer platform. So thanks to the easy access to the data sets, you can, in one place, get the data sets and also process those data sets. Using Python, getting access to data through SDK. You can build your own processing chains, and you can use also the analytical blocks, processing blocks, which helps you to process the data sets with already prepared algorithms. Then how can UP42 help scale your business? Today, our focus is construction monitoring, but of course, our users, our customers are working in a very different sectors, conducting very different projects, both commercial and also research. So we see that in all areas, UP42 platform can be easily used and projects can be easily conducted. First of all, we simplify the geospatial data purchase process. In many cases, for your projects, you need different data sets, both aerial and satellite, also weather data. So instead of going to different data providers, you can access all of those data sets at UP42 platform. Getting started to work with UP42 platform is very easy because the user interface is very friendly. And because our platform is cloud-based platform, this environment is very flexible and scalable. So it's actually tailored needs to your needs. So thanks to this flexible environment, you can build your own processing chains. So starting from one step and then adding and more and more steps, you can build the whole process of first getting the data sets and then processing the data sets and getting really valuable outcomes of this processing. On each step of working with UP42 platform, you can always get help from our customer success team. They are ready to help you on each step and lead you step by step through UP42 platform. I encourage you all to test UP42 platform and see if it meets your requirements. So after this short introduction to UP42 platform, I would like to welcome on stage Andy Millard, Customer Advocacy MEA from Vexel Company. Andy will give us a presentation about Vexel aerial imagery and how it can be used in construction project planning. The floor is yours.
Thanks, Claudia. I'll just start with a brief overview of Vexel. So Vexel is a 30-year-old company, celebrated our 30th anniversary last year, and basically we're split into 3 divisions. Our main section, the oldest part of the company, is based in Graz, which is our camera development and building division, and they build the world's leading aerial imagery cameras. We then have a fleet of aircraft in the US fitted with those cameras that capture data for us. Outside of the US, we commission independent flyers who've got our cameras, and they again capture data for us, which then feeds into the Vexel data program, which makes us the world's largest aerial data provider, and we've got data captured in over 30 countries. As you can see, we've got Canada, US, Puerto Rico, UK, and all of Western Europe, and we're starting to move further east with Czechia and some of the Baltic states as well being captured. Oops, that's sort through. We've also captured the main areas of Australia and New Zealand, the main population centres, and also we're in the process of capturing the whole of Japan. The products that we produce, we've got high resolution aerial imagery, 7.5 centimetre or 15 centimetre. The 7.5 centimetre is our urban data capture program. The 15 centimetre then is outside the main population centres, and we capture that at 15 centimetre. The accuracy is unmatched. We use survey grade ground control points. There is no data shift in we also capture digital surface and terrain models, and those fit exactly with our aerial imagery. So let's look at how Vexel's aerial imagery can assist with construction monitoring. First of all, project planning and design. Aerial imagery can provide high resolution, up-to-date visual data that can aid in project planning and design. It allows planners and architects to accurately assess the existing conditions of a site and make informed decisions regarding the layout, orientation, placement of structures by bringing in additional layers such as development corridors, or technical drawings as well could be brought in. Alternative routes can be overlaid to assess which one would be the best route. We can zoom in to level 20 on our 15 centimetre resolution imagery to clearly see what is on the ground and where the route would impact the vegetation and the terrain in this instance. We can then do site analysis. The aerial imagery can be used to analyse the topography, vegetation cover, other physical characteristics of the site. This information is crucial for understanding the feasibility and potential environmental impacts of a development project. It can help identify potential challenges and inform decisions regarding grading, drainage and landscaping. The imagery can be used in your preferred GIS solution, or you can use it within our Vexel viewer, where you can also add layers such as protected trees and see where those trees are. We can also use the DSM and DTM in the background, but simply by clicking on the image, we can get the height. So in this instance, the height of the lake, and then click along the road to see the various heights of the road as it passes between those lakes there. Progress monitoring. The aerial imagery can be used to track progress of development projects over time. By capturing regular aerial surveys, stakeholders can monitor the construction activities, evaluate the adherence to timelines, and identify any potential issues or delays that may occur during the project. This can aid in effective project management and decision making. Here we have the 2020 imagery. You can see that very little work has started on that site. 2021, you can now see that some development is occurring, and by the 2022 capture, you can see that bridges have now been built across that lake as part of the rail infrastructure that's being built. Because of the accuracy of the imagery, we can measure the width of the bridge here, so 10.5 meters. We can also, using our DSM DTM, measure the slopes here. So we've drawn a polygon, it gives us the area of that polygon and also the degrees of that slope. So a 14-degree slope on that particular part of the roadway there. We can also select a point and then do the height above that point of any object. So in this case, the silo is 14.2 meters higher than the base point that we have selected. Environmental impact assessment. Aerial imagery again assists in assessing environmental impact of development projects. It can be used to monitor change in land use, vegetation cover and water bodies, helping to identify any adverse effects on the ecosystem. This information is crucial in complying with environmental regulations and implementing mitigation measures. In this example, it is clear over the 3 data captures that the development is having an impact on the water level. And you can see that the size of that lake has shrunk somewhat, and that vegetation is now taking hold on areas that were previously below water. Final part, asset management. So after the development has taken place, you can use the aerial imagery to assess how assets are being maintained, and so assess how the age of the structures and support long-term planning for repair or replacement. And we've got a project ongoing in the US where we've used machine learning to identify road markings, and then using artificial intelligence, we were able to then determine the condition of those road markings and highlight those that are in need of repair, repainting, and even taking it to a stage where we can identify areas where the road layout might need changing to improve safety for both pedestrians and cyclists. Overall, aerial imagery offers a powerful tool for monitoring development projects, enabling better decision making, improving project management, and obviously the imagery can be used then in documentation to converse with the public on how development is progressing. We're pleased to be part of the UP42 platform, and all of our data is available on that platform through UP42. And I'd like to now hand back to Claudia.
Thank you very much, Andy, for this interesting presentation. I see already a couple of questions to your presentation, but let's get back to those questions at the end of our webinar. Thank you very much. So let's move on to the second part about satellite data and InSAR. So please welcome on stage Dr. Oliver Lang, head of SAR from Airbus. Please, Oliver, the stage is yours.
Thanks, Claudia. And hello, welcome, good morning, good afternoon, wherever you are. So this is about using SAR, synthetic aperture radar images, for construction monitoring purposes. And I have some terms here in the title. It's InSAR, it's high resolution. Let me explain shortly what this is about for those who are not really familiar. So what is InSAR? It's a term for interferometric SAR, interferometric synthetic aperture radar. And this technique is used in order to measure surface deformation, surface movement effects with a millimeter precision. How does this work? The core principle is quite straightforward. So you take a couple of SAR images, either from satellites or from airborne, but let's speak about here on the satellite imagery. You take them, you co-register these images very, very precisely, and then you measure the runtime differences between different acquisitions. And if there was a movement effect on the ground during the period of observation, symbolized with this red fraction in the upper right figure, we can measure that with a fraction of the wavelength of the signal. The wavelength is 3 centimeters. We measure a fraction of that, and this gives us the millimeter precision. And if we don't do this only for a pair or 3 images in a row, but for whole stacks, being about 20, 30, 100 images over a time span of months or years, we create a time series for millions of points for the whole image. So this allows then for a retrospective view on the surface behavior, on the deformation, but also allows for a monitoring along with construction activities. You will see some maps here, some examples which are colorized. The typical color scheme is in a way shown here. Everything which is green is stable. Everything which is red or yellow seems to subside, and everything which is more blue uplifts. Let's have an example right after. So what is the data sources which are inputs? So these are synthetic aperture radar. Our data source in Airbus is TerraSAR-X or the TerraSAR-X family. We call it the radar constellation. It's a family of 3 satellites, where one of these, the PATH satellite, which runs in a constellation, is owned by a Spanish partner, Histoset, while 2 are German national satellites, where Airbus owns the commercial rights to sell the data or to value add the data. What is the specialty of the satellite of this system? It's the precision. So we can measure with a very high precision, because we know exactly where the satellite is at a given time in the orbit, down to a few centimeters. And this is a precondition for precise co-registering and for this precise measuring capabilities. It's quite a flexible solution in terms of what is the sampling you can apply on ground for such a monitoring purpose. The lower limit is 4 days, and you can go up to 7 days, 11 days, or multiple of these numbers, depending on your specific use case. So you create a sample of images over time with a given sampling interval, and This allows you to generate lots, millions of measurement points per scene, and to create efficiently and with quite a low cost compared to in situ measurement, local measurements on ground. So what we have as here in this example is, this example represents more or less the strengths we have in such an InSAR data set. So on the upper left, we have a rasterized view of a city. In this case, it's Hamburg. This is what you're used when you're applying or using satellite imagery. You get a total view, get a raster image. In this case, it's a colorized in terms of the movement effects. But with this InSAR technique, with this kind of product, you can do a deep dive into. If you zoom in, you can see the movements which are relevant for specific infrastructure elements here. In this example, for example, we have here a rail track which moves, and we got a single point. We selected a single point out of millions of the points, and for that we have this time series created during the observation period. So the InSAR spans at the end has the best of both worlds. We have the raster overview of a very large area, but we have also the in-depth view of single points with a very high precision at the level of a ground measurement technique. High resolution is another term. What does it mean? Yeah, let's compare the TerraSAR resolution here, a strip map scene with a 3-meter ground resolution with Sentinel, which is a free data source, as you're probably aware of. Sentinel-1 is the radar space source with a resolution of approximately 20 meters. So these dots here in this area represent measurement points in the interferometric analysis. You see, it's not totally homogeneous because interferometry requires some kind of stability. So over vegetated areas or over water, we won't get any measurement points. But for infrastructure elements, there are usually there's a high point density. You see on the left side the Sentinel result showing some movement effects on a road. If we do a zoom view with the TerraSAR of the same area, we can clearly discriminate that these surface movement or subsidence effects are related only to the half of this highway. Of course, this is a compaction effect resulting from some maintenance work before. So this demonstrates a bit that high resolution is a very good choice if you want to have a detailed look at specific infrastructure elements along with the construction work or afterwards, or if you want to do some kind of or create some kind of a baseline result to have an understanding on how was the situation in the past and how does it compare to the situation today with respect to surface movement effects. Another example here, it is Sydney. We have major tunneling activities ongoing here. This is a result created over 3.5 years, again with the 3-meter mode. On the top left, we have this overview image. You see those orange pattern which follows the tunneling. On the lower left, this is a selection, a subset of these points, a zoom in and a subset. Highlighting only those points with a substance of 2 millimeters per year or faster. And this highlights very well what the corridor is of the surface deformation effects. And this is not homogeneous. And this is very interesting, not only for the construction company, but also for the authority and also for, of course, for the public on how far and what's the amplitude of movement, how far does it distribute in terms of a spatial dimension. And we have also this temporal effect on the lower right. You see this time series for the green point and the red point in the figure on the lower left. And we clearly see that subsidence for the red point started earlier, a couple of months earlier, and for the green point later on, because that exactly represents the speed of the tunneling machine underground. So it's also a third component inside, or third dimension, it's time, temporal change. If you think that is interesting for your application or for your purpose, I have a good piece of information for you. You get some free sample data, full data stacks capability to run an interferometric study on UP42. You can download it for free. We have 4 data sets. You see it on the right, which one these are: Silicon Valley, another close to San Francisco, and 2 data sets in Delhi, in India. We have the 3-meter mode and the sub-meter mode, the spotlight mode, a stereo spotlight mode has 25 centimeter by 1 meter resolution. So very interesting. All stacks have at least 30 images, free of use. You can do anything you want with these. The only thing you cannot do is to sell them, but anything else is doable. The license very relaxed for usage. In addition, I have highlighted here in the marketplace the WorldM product. We have a couple of WorldM products from Airbus. This is a homogeneous pole-to-pole digital elevation model, which is very well suitable for interferometric analysis, but for many more as well. So this is a very good input for that. So a last slide before I do a very quick demo. This is the result for the Silicon Valley. You see a lot of movement in the Silicon Valley, driven by groundwater extraction. This is exactly generated from this free data set. Anyone can download from and train and test from the UP42 marketplace. So feel invited to use them. A very interesting data set. We got 40 million measurement points here, quite a massive amount of points.
So now I would like to welcome on stage my colleague Alex Bishop, our pre-sales engineer, who will show us how to get easy access to those different geospatial data sets. Alex, the floor is yours.
Thank you, Claudia. Hi, everyone. My name is Alex Bishop. I'm a pre-sales engineer with UP42. I'm really lucky because my slide deck is only 1 slide. And then we'll go straight into our demonstration of the platform. This is it. Essentially, I just wanted to provide a baseline of what it is that UP42 does. And we sit at kind of the center of a network of partnerships. And our mission is really to simplify access to a variety of data sets. Because as perhaps many of you guys have done, I certainly have, sometimes we have to look for data on Earth Explorer or on ESA's websites or directly with different platforms and data providers. And that can be cumbersome and difficult with a variety of compliance levels to pass and subscriptions models to have, where UP42 allows you to kind of use and consume the data you need and you pay for what you need as you go. As we'll see with the demonstration. So a variety of providers can be accessed through UP42. These can be rasters, vectors, and more. And you can do this in 4 ways. We are an API-first company, so our REST API is the most feature-rich, but you can also work with the Python SDK, the console UI or the web console, which is what we'll look at today, and our Esri add-in for those of you who work with ArcGIS Pro. Okay, so that being said, I will start sharing my screen and hopefully I won't disappear either myself. So let me go to this window here. Okay, fantastic. I will assume everyone can see my window. So perhaps some of you have already done a certain level of discovery of UP42. But for those of you who haven't, once you log into your account, you land on this dashboard page. And it's a really convenient place for finding general information about our capabilities. You can see our 3 main pillars right here, actually: ordering archive data through the catalog, tasking data, and processing components. You can view, your available credits, explore sample data sets, and so forth, and you have some links to documentation and support on the bottom. We also have a nice notifications center, and you can efficiently search our documentation directly here with this search button. But for the fun stuff, which is finding data, you simply navigate to this catalog tab right here. So today I'm going to show you for a given geometry how you can discover available data sets. As you can see, when you log in here to the catalog, you're presented with a typical web map type interface. You can just off the bat run an archive search just over wherever that you're located. You also have the ability to draw, kind of a rough outline of a geometry if you want to. But the best component is, building your geometries. You might be getting them from your own customers. You have these very well defined, perhaps from GPS surveys, and you can upload geometries using this upload function up here. And we have access to a variety of formats. GeoJSON is our preferred one, but we also have KMLs and well-known text. And as you can see, as soon as I upload my geometry, an archive search is automatically run. And you're presented with the variety of data sets that are available over the geometry that we've provided. So just off the bat, you can get the nice quick view of available archive, or at least available sensors, right? A variety of data sets. We have very high resolution ones. We have high resolutions and medium resolutions, Sentinel to be an open source. And we also have elevation products down here. And it seems over this particular geometry, we don't have radar for this particular area. And this is great because, it shows that perhaps at different stages of projects, you might want to see, what products are available and different resolutions. But if you wanted to discover, say, more about Pleiad Neo, you can go ahead and click on this drop down. You're presented with the 3 most recent returns, but if you wanted to view the full archive, you can simply do so by clicking on that other button. You can refine your search by setting filters. So perhaps you need to fine-tune the cloud cover. Maybe you don't want to go too far back in time. Let's go to 2021, for instance. And this will simply, modify the results for this particular area. This is a cool example because it's actually over a construction site here in Georgia. And you can plot, you can see, the temporal, the cadence here of acquisition over this site. So this is another advantage, perhaps, of satellite imagery over some of the aerial providers, where we can have more frequent revisits over specific sites. And so that, is a good example we're seeing here. You can plot low resolution previews of the data set. This is nice and convenient because you might want to confirm whether or not there's some cloud cover over your geometry. Even though it says it's only 0.5% cloud cover, you can see that one of these was actually quite close, but it looks all good for this specific scene. And you also get some information about the metadata of this product. You also have a link to some sample data sets if you wanted to go through the sample data sets route. If you were happy with this and you wanted to purchase it, you can choose between different processing levels, so an analytics or a display product, depending on the interpretation that you're trying to get to. Display being, optimized for visual inspections, for AI and ML models, and so forth. We can add this to our cart, and we can perhaps, go find a different data set if we wanted to, and add it to our cart again. If we wanted to check out and purchase this, we simply follow the checkout instructions. We get a breakdown of the cost, and we can order the asset. Once the order is submitted, it is then delivered into our storage component, which we'll have a look at in a minute. And so the benefit here, again, is leveraging the access to a variety of data sets. This is specific to the archive. But say there isn't any available imagery over our site for a given time frame, we can also use the tasking component. The interface is somewhat similar, where we have access to our web map type web map interface, and we can upload our geometry, select a collection that we might want to task. So let's go with the pterosaur. And all we have to do is fill out our order form. We can provide a description, set some time ranges of the acquisition period. So how about we'll start here and we'll end in a couple of months. Why not? Acquisition mode, spotlight, polarization. How about that? And then single look is quite nice. And we can add some tags. And this is really convenient because you can then, from a project management point of view, define, hey, this particular tasking order is for, Georgia DOT. And from the acquisition and all the way into your storage, this tag will live with this data set. And that was really convenient for referencing and managing your data on the back end in the storage side. So we could do GA DOT, for instance, and we'll do test. Add that and add. Cool, so now we can move on. We get our nice order summary and we can submit our order request. And I took too long, but that's okay. When orders are submitted, you find them here. So your orders management page, as you can see, I have a couple that are in progress, a few that are complete. One is ready for the price review, which you can kind of dive into and have a look and pay and activate the tasking order. One has a feasibility study. For those of you who are familiar with tasking satellite data, you'll know that this is a step that you need to go through a lot of times for optical data sets. And again, I can choose and confirm which option I prefer. Finally, when these processes are successful and acquisition is done, whether it's for the catalog, the archive, or tasking, data sets are then delivered into your storage account. And from a management point of view, this is pretty awesome because it's stack compliant. So you can search for data sets. For instance, we can search for a specific tag. So say I want to find all my projects that I have an infrastructure tag, and I can quickly run and filter out for those. So I can see I have a couple of Massachusetts DOT projects. I have some airport authority ones, and I can, kind of dive into these and see which data sets they are. I can do some metadata about them. I can view the geometry of the AOI that was used. I can download it from here or view the size of it. And for those of you who are interested in using the SDK or the API, we also have a bit of code snippets down on the bottom. We can dive in a little bit more even. This space will be evolving in the future. I think eventually someday you might even be able to see the data set itself here. But certainly for now, you can at least get a view of the acquisition dates for that particular scene. So something I want to mention is, because I saw a question about, resolutions and products and identifying what might be good. This really depends on, knowing what it is that you want to try to identify. When you have access, kind of at your fingertips at so many different data sets, it's important to think, at what stage in my project am I? Which data set might make sense for that? And obviously, this is great because it allows you to kind of modulate and spend the money on a data set that is needed at the right time. Maybe you don't need the super high resolution always. Perhaps you start with VXL at the beginning because it's very accurate. It's a super high resolution product. And maybe you get a VXL product every year, but you also get satellite optical data every month or every couple months. Maybe you want to leverage the tasking every 6 months and ingest archive as it comes in. So this is the beauty of these types of platforms. An aggregator, as we are with UP42, is that you have the freedom to kind of pick and choose, pay for what you need. You only are delivered the data sets that intersect your geometries. So defining those geometries is really the fundamental step. That's the basis of the data that you'll be delivered. And so that would be, the best place to start. Last thing before I hand it back to Claudia, if you guys are interested in learning more, I invite you to have a look at our documentations page. Going here under the tasking and catalogs section, you'll have a nice view of all the available data sets that we currently offer. the integrated and non-integrated for now, and also the marketplace where you'll be able to even dive into more specific details of the different offerings. So I will end my demonstration there. Hopefully this was interesting to everyone. And Claudia, I'll pass it on back to you.
Thank you very much. Thanks, Alex, for this demo. Very interesting. So I think this is the high time for the Q&A session. So please, let me welcome on stage again our great speakers. So Andy, Oliver, and Alex, back again. So let's go to the questions. Some of your questions has already been answered by our team, but I see a couple of questions which we can read now, and I will address those questions to our experts. So let's start from the beginning. Andy, this is a question for you. Andy, how do you measure height on the image? You have underlying LiDAR data as well?
No, we don't use LiDAR. Due to the way that we capture data with sort of 80-90% forward overlap, 60% side overlap, our software then, Ultramap, is able to create a dense matching, which generates a high resolution, highly accurate point cloud from the imagery itself. So that 3D point cloud has 300 points per square meter. So that's given us that very high resolution and accurate DSM.
Okay, thank you very much. I hope this was the answer, the place you expected. Okay, so let's move on to another one. So question from David. We're interested in knowing whether a construction project has started yet, such as particular multi-acre solar installation. We don't need a very high resolution, but we don't need broad US coverage. So which of the technologies are most appropriate for that purpose? So I think that maybe Alex.
Yeah, happy to answer that one. Yeah, absolutely. It depends, it depends what it is you're trying to identify. So say the project hasn't even started and you're just trying to see if there's been some forestry clearing, for instance, or any type of clearing if they're bringing on large, materials, construction materials, then perhaps a low resolution product is good enough, right? For this kind of there's big changes happening in the environment. We don't need to see the fine granular details of them, and perhaps something like spot data is going to be good enough, or perhaps something like 21AT or Satellogic Black Sky, some of those, right? And it's going to depend on the size of your geometry, also, of course, your budget. And so I would go perhaps with one of those. But then as the project moves along and say you need to start counting the solar panels, the installation, getting estimates of the capacity that's being installed there, well, then you might have to go up in resolution, because you'll need to be able to at least see and where the pixels, if a spot data set pixel is at 1.5 meter, well, maybe that's too low. And maybe you need to move to something like a Pleiad or Pleiad Neo even, right? And so it's going to, I would say, depend on the stage of the project. But in this case, if you're just trying to see if something's happening on site, you can certainly start with a medium to medium high resolution product, I would say. Yeah. TerraSAR, a radar could help there too. Obviously, I think a radar, because vegetation reflects the radar bands in a specific way, but now if they're bringing in materials, they might reflect more, right? So you have metals being brought on site, perhaps you'll start seeing reflections there that weren't there before. So radar could also provide some sort of help. Aerial imagery will depend on the revisit frequency, which might not meet your requirements.
Okay, thank you very much. And then we go to another question by Neil. What is your plan to improve revisit beyond 4 days? I think that was a question to Oliver.
I guess so. Yeah. First of all, sorry, my connection totally broke sudden, so I was not able to finish my presentation in the live demo. Anyway, I hope you got the key points from the presentation I was able to run through. On your question, yeah, it's a good question, a valid question. I said we have a revisit time of 4 to 11 days. If you look at other constellations, so they also vary. But our plan at Airbus is not really to change that mode, because that serves most of the needs. At the end, the revisit time is driven by the orbit geometry. And the radar constellation, TerraSat, Tandem, and Path are running in a given geometry, and we won't change that. If we look in the future, it might be the case that we launch new missions with a different mode, but for the time being, and also for the midterm future, this is the setting.
Okay, thank you very much. Okay, so the last question from Joanna. Hi, do you also have data from L-band SAR constellation? So also I can answer this question. Unfortunately, at the moment, we don't have any L-band SAR constellation. We have SAR data from other different providers, such as Capella, InSAR, Airbus, of course, or Synspective. But all of those data sets are in X-band. But we are actually talking with other data providers. So maybe soon L-band will also be available at our UP42 platform. Okay. So that was all. I think that the rest of the questions were answered during the presentations. So at this point, I would like to thank you all very much for attending the webinar. And also I would like to thank our great speakers, experts in aerial imagery, SAR data, geospatial technology. I would like to thank you for presenting very interesting use cases. And thanks to those presentations, we could learn a lot how geospatial data, such as aerial imagery, satellite imagery, can be used in construction monitoring, planning, used on different stages. And all of those data sets are available through UP42 platform. So you can access those data sets and also process those data sets at UP42 platform. I encourage you to test UP42. Thank you very much. I hope you enjoyed the webinar. And as mentioned at the beginning, we will send you an email with the link to the webinar in a couple of days. Thank you very much. Goodbye.